And your designation?
It is domestic marketing, like sales and marketing, you can mention
Head
as
level.
GM sales and marketing.
Yes.
Yeah, that's okay.
Yeah. Uh, a very good afternoon to everyone present here. I, Dr. Rajkumar Arya, Associate Professor in Department of Chemical Engineering, NIT Jalandhar. I welcome you all to this, the last session of this online international course on current and future scope of surface coatings organized by Department of Chemical Engineering. The convener of the course is Dr. Sangeeta Garg, Head of the department, and the patron of the course is Dr. Lalit Kumar Avasthi sir, the Honorable Director of Dr. B.R. Ambedkar National Institute of Technology, Jalandhar. So the speaker of this session is Dr. Navneet Kumar, who would be talking on barrier coating in food packaging applications. So before we start the session, let me introduce you to Dr. Navneet Kumar. We have amidst us Dr. Navneet Kumar, who is the General Manager, Sales and Marketing with Uflex India. Dr. Kumar is enriched with over 19 years of experience in multiple leadership roles, being international and domestic sales, business development, manufacturing, and quality assurance, etc. Prior to joining Uflex, he was the head of sales with Jindal Polyfilms and looked after Europe, Middle East, Africa, CEA, and handled business size of crore 250 per annum or 2000 ton per million metrics. Dr. Kumar was also associated with Max Specialty Film as a head of zonal sales, North and East India, as well as head of business development. He was also associated with Cosmo Film Limited, New Delhi in various capacities. On the educational front, Dr. Kumar completed PhD in business development from École Supérieure Robert de Sorbonne, France in 2019. Earlier, he completed his BTech in polymers from SBTI Kanpur in 2001. He is also the recipient of several awards and recognition during his studentship. I would also like to mention that Dr. Kumar is my BTech classmate. We did BTech from SBTI Kanpur in year 2001, and he is working in industry and I am in academic fronts. So with these brief introductions, now I would like Dr. Navneet to conduct the session. Over to you, Navneet. Navneet, your mic is off. Navneet, please turn on your mic. Your presentation is visible.
Yeah, now I believe it is okay.
Yes, 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 yes.
So this is the first slide. Is it visible to all?
Uh, Actually, it's you have to go to that window actually where you
Okay.
have PowerPoint.
Present now a window.
Yeah, you can do that way. A window also and means a screen
Yes.
also, both works fine.
So now is it
Now it's visible. Yes, yes, yes.
so do I need to
Yes, yes.
like full screen, or is it visible as it is?
Full screen is better, so if you can do it, it looks better
Now
if
it
you
is
read and
okay.
understand. Yeah, now it's good. Yes, 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 yes,
Okay.
perfect.
So good afternoon, everybody. And so I mean, my little introduction is already given by Dr. Arya. I have mentioned my contact details as well in case someone is interested to contact me over email or over my mobile phone, WhatsApp, etc. One thing I want to mention that I am presenting this session in my personal capacity because I was working in Jindal Group when we agreed. I mean, for this session, me and Arya, and now I am moved to Uflex Group. So this presentation is having mainly the academic kind of thing. It is not like promotional activity, or it will not have any kind of brand names or product name, but a general idea on the packaging. I mean the barrier coating. So this is our index. How we will go ahead. There are two short breaks, story time, and what is barrier coating. Everything about barrier coating we will do. So in packaging industry, mainly three barrier coatings are more popular. That is PVDC, acrylic, and alox. So we will talk on this in detail, but we will touch base on other coatings as well. Uh, there are certain coatings which in packaging field are called treatment. For example, we do some chemically treated film, or so we do not treat that terminology in coating. So that I will explain you, and then I will explain some applications of flexible packaging, which is more relevant to food, and we can have some discussion because these are the visual images, like what kind of barrier is required or how the problem is solved. So the question is, what is the barrier coating? So barrier coating is something to prevent the penetration of gases, light, aroma. It can further extend it like chemical, UV, CO2, grease resistance, etc., etc. But in industry, 80% of things or around that are captured in oxygen barrier, moisture barrier, and aroma barrier. So we will discuss on these 3 points more, and maximum coatings are for these purpose only. This is uh, the diagram or a plot where we can see there are various kinds of um, material. The one axis is OTR, another axis is WVTR. So we normally consider the aluminum foil or glass or steel as the highest barrier material. So this is like 0.01, 0.01. The reason it is not counted as zero, because in aluminum foil also below a minimum thickness, there are certain pinholes in some frequency. Therefore, it cannot be treated as 0, 0. So when it is laminated into the laminates, generally the barrier value increases, but yes, it is not a 0, 0. It is treated as 0, 0, but it is not exactly 0, 0. Then there are the last one is the polyethylene, which is not a barrier material. It is having the value of OTR around one between 1,000 to 10,000. Metallized PET is something which has emerged as one barrier product. Nowadays, people are using polyester film in three optical density. Optical density is mainly the measurement of how much aluminum is deposited or in the on the surface of the film. So this particular film is now people are using in place of aluminum foil in certain application like dairy creamer or some coffee pouches, etc. Then there are alox material, PVDC material, EVOH. So these are the red circle is the range which is normally used in the food packaging, like mainly in the meat packaging. But this is the circle which we are focusing on as the barrier properties for the food packaging. Now, just a quick brief on what kind of plastics we are using and for what are the main application. Like polyethylene is one which is the one major portion of the laminate. The main property which we are using is heat sealable nature, and it's a food contact layer. Therefore, in the maximum snacks, we are seeing that the inner layer is polyethylene. It is having a moisture barrier, and it can be combined with gas or aroma barrier like PAEVOH, because we cannot use it as a single layer. So some application may be like breathable packaging where we are not using any kind of barrier properties. We can use that. Carton liners, LLDP is used. The another big category is the PP, polypropylene. It is having it is having a good moisture barrier, but it is having a poor oxygen barrier. So this is a limitation of these polypropylenes. It is having good mechanical property. It is having a good heat seal coatings like PVDC, etc. When we do so, the application modified atmospheric packaging we are using microwavable packaging, hot fill application. So this is a widely used product. Like by PP, we can make films like there's a term called TQPP, thermally quenched polypropylene. This film is used mainly for the bread application, and BOPP is used for the another segments, including bread, um, in the form of a laminate. Then there are polyamides, which are having a gas and aroma barrier. They are used in thermoform packaging and boil in packaging. Then the one of the most important product is PET. So PET films are very popular and common mainly in India, in Europe or in overseas market. The BOPP demand is high in food packaging and polyester as well. This is having gas or aroma barrier, a very good moisture barrier to provide mechanical strength, heat resistance. This is one of the main property which is utilized in many applications. So PET is used in bottles, PET bottles, cheese packaging, sterilizable pouches, etc. Then comes the polystyrene. This is known for the printability, gas permeability. This is used for breathable packaging for fresh product like fresh meat packaging. Then EVOH. EVOH is known for the oxygen barrier. However, in India, this material mainly used in the co-extruded layer in the plant itself. So many people do not treat this as a coated material, but yes, it is a material which is used for the barrier properties. So this is used for the atmosphere packaging and packaging of oxygen sensitive food. So it gives a very high level of aroma barrier and oxygen barrier. Then the PVDC. PVDC is very good for the, this is used in the form of coating. The most common is people are using 1 or 2 micron coating on the polyester film. This is the most common application of PVDC coating. This is having gas barrier, aroma barrier, moisture barrier, and this is used to protect the film to film surface, scratches and abrasion. This is also used in some extent for the peelable nature also, in case we modify the recipe little bit. In outside countries, PVDC coated films which are anti-fog also are used for the cheese packaging. So Netherlands is a very big market for this kind of films, the PVDC coated BOPP films. And the another is the EVA. EVA is having a very good moisture barrier, and this is used with BOPP or polyester. In both, it can be used. So modified atmosphere packaging applies at coating or co-extruded film. EVA films are, this is used in the form of coating like offline coating. Other than the some food packaging, this is also used in the paper lamination or board lamination films. EVA is a very heat sensitive material. When we apply heat and pressure, then it is laminated. Then polycarbonate is a heat resistance, mechanical strength and moisture barrier. This is used for microwavable packaging, hot filled packaging. The another films are PVC. It is for the gas and aroma barrier. It is having good mechanical strength. Fresh food application is one where it is used. And then this is the polyethylene naphthalate. These are the special kind of material which is used for hot refills, rewashing, reuse beverage bottles. Then this is the PETG, which is a new and emerging field. Um, in case of PVC shrink labels, PETG labels are now more common, and in mainly in Europe, PETG is used in shrink sleeves rather than the PVC shrink. So this is almost all kind of plastic polymers and where these are used. Now we come to the barrier values of packaging films, because in industry we normally use BOPP polyester, then we do metallizing and it becomes metallized BOPP and metallized polyester. To some extent we do ALOX coating on PET, so this is the coated version. So these are the OTR and MVTR values. ALOX PET is very good in terms of the barrier. Aluminium, as I mentioned earlier, we do not write OTR and WVTR 00. However, in some cases it can be close to 0. So if we see one by one the plain polyester, the WVTR ranges from 18 to 75 and OTR is 30 to 175. If we go to BOPP, which is the third one, the plain BOPP, the OTR value is not good. I mean, it is quite high.
What is this OTR thing?
Pardon?
What is this OTR?
This is the oxygen transmission rate, and WVTR is water
Water
vapor
trans.
transmission rate. So,
Okay. Thank you.
so this is the cc per meter square per day, like how much oxygen is passing in certain conditions, which are the test conditions, per meter square per day. And in WVTR, it is the quantity of moisture in gram per meter square per day. So BOPP is not good in terms of the OTR. So good, when we say good, means the value should be low. If the value is tending to 0, it is better. When we metallize both the product like BOPP and polyester, so metallized BOPP value reach up to 80 and metallized polyester 1 to 2. This I'm talking about the normal polyester. So if we want to make the polyester further, um, I mean, having more barrier value, then we increase the optical density of the aluminum or the metallization. So then this value can be like 0.03 or 0.04. This is achievable and which is also sufficient in many application. Then Eloxpat is there. We will discuss Eloxpat in detail. Uh, I mean in next slides. Then aluminum. Normally aluminum can be. I mean there may be multiple thickness, but normally people are using from 7 micron to 12 micron in various applications. And the other than the barrier, there is one more property of aluminum foil is it is having a dead fold property rather than the barrier. I mean barrier is there and also the dead fold is there. So if you have seen this Amul dahi and etc., the upper lid is made of aluminum foil. So once you fold it, it will be in the folded position. And if you see various drinks which are in the cup in the similar shape, so this is having some kind of lidding material, not having aluminum because the barrier is not required there. And this is not having a dead fold property. So other than barrier, the some other properties may also be required in some cases. So this is the story time because I believe it is completely theoretical and technical. So it's a very short story. I will, and then we will move to our next topic. The approach matters. So I will share this story in Hindi because this will be more connected that way. So,
So this is the actually just a natural barrier in egg cell, no?
हाँ, yeah,
Yeah, okay, okay. Yeah, yeah, yeah. Continue, continue.
yeah. So this is actually a motivational story. Approach matters. So पुणे से मुंबई अंडों का ट्रांसपोर्टेशन होता था और बहुत ज्यादा मात्रा में वो अंडे टूट जाया करते थे, say around 90% or more. Just a theoretical example. तो जो भी एसोसिएशन थी उन लोगों ने मीटिंग की कि हमें कुछ अच्छा करना चाहिए और हमें उन अंडों को टूटने से बचाना चाहिए. द फर्स्ट आइडिया केम अप इन माइंड कि हम उसके लिए क्रेट्स बनाते हैं, जो क्रेट आप फोटो में देख रहे हैं, सिमिलर काइंड ऑफ क्रेट. सो द क्रेट वाज डिजाइन, लेकिन अभी भी अंडों का टूटना जारी रहा. देयर वाज हार्डली 1% इम्प्रूवमेंट. दूसरा आइडिया इमर्ज हुआ कि हमें इसमें पेपर कॉटन का यूज करना चाहिए, पेपर और कॉटन का यूज करना चाहिए. तो लोगों ने उसको यूज किया बट हार्डली देयर वाज एनी इम्प्रूवमेंट. फिर लोगों ने कॉटन से अलग अलग स्ट्रक्चर्स बना के उनको यूज करना शुरू किया कि भाई अंडे किसी तरह टूटना शुरू हो, टूटना खत्म हो. बट देयर वाज हार्डली 1% इम्प्रूवमेंट. प्रॉब्लम सॉल्व नहीं हो रही थी. फिर सडनली एक आदमी के दिमाग में बहुत इनोवेटिव विचार आया कि ये अंडे झटके लगने की वजह से टूट रहे हैं, तो हमें रोड पे ध्यान देना चाहिए. तो उन्होंने पूरी नई रोड बनाई, लेकिन स्टिल देयर वाज हार्डली 1% इम्प्रूवमेंट. द प्रॉब्लम वाज नॉट गोइंग टू सॉल्व. कुछ लोगों ने ये विचार दिया कि हम अंडों को बॉईल करके मुंबई भेजना चाहिए, इससे उनके टूटने की पॉसिबिलिटी कम हो जाएगी या खत्म हो जाएगी. बट दिस वाज नॉट द प्रॉब्लम. दे वर नॉट एबल टू चेंज द प्रॉब्लम. द प्रॉब्लम वाज टू सॉल्व हाउ टू ट्रांसपोर्ट फ्रॉम पुणे टू मुंबई. फिर एक नया आइडिया इमर्ज हुआ कि वी शुड टेक अ वाटर टैंक एंड वी शुड पुट द एग इनटू द वाटर सो इट विल हैव अ वेरी गुड कुशनिंग इफेक्ट. वो भी ट्राई किया गया. इस तरह अलग अलग आइडियाज आते गए. किसी ने बोला कि ट्रेन में ले जाओ, किसी ने कुछ, किसी ने कुछ, वगैरह वगैरह. तो ये प्रॉब्लम काफी टाइम तक चलती रही. फिर सबसे रिच आदमी सामने आया, उसने बोला मैं इस प्रॉब्लम को सॉल्व करना चाहता हूँ इरिस्पेक्टिव ऑफ द इन्वेस्टमेंट. तो उन्होंने अपना लास्ट एक्सपेरिमेंट किया विच वाज टू यूज सिल्क एज अ मटेरियल. उसके ऊपर उन्होंने एग्स को रख करके ले जाने का प्लान किया, बट फिर भी प्रॉब्लम सॉल्व नहीं हुआ. तो उस फोरम में एक आदमी था, उसने बोला कि ये आपकी अप्रोच गलत है. उसने बोला अप्रोच तो हम लोग इतने सारे लोग लगे हैं और इसमें और कुछ करने लायक नहीं है. सो ही in case someone have any innovative idea, I mean, you can share so that, then I will come to the answer. I mean, anyone can participate if something is left.
Yeah, I can say something from my side.
Mm-hmm.
So yeah, because the पहले वाले का कॉन्सेप्ट ठीक था, बीच वाले का कि झटके लगने से वजह टूट रहे हैं, बट द
Mm-hmm.
approach further by making the road was not good at least,
Right,
because in that case इस ट्रे में ही झट मतलब शॉक को मतलब जो है absorb करने वाला कुछ कुशन लगाया जाए,
right,
so that would be much more better.
right. Yeah, I appreciate your thought. Anybody want to share any view? Like,
Yeah, because all of us must share something, because then it becomes interesting actually.
okay. So I
Basically,
think,
positioning of egg is important. Orientation
right,
rather than questioning.
right, absolutely right, right. Yeah, good approach, good attempt. So anybody else want to try this problem? I mean, if you are the member of that team, then you can give some suggestion. Like two good suggestions are given by Dr. Arya and one other participant. Anyway, we move further. We will not take much time on this problem. So the person explained कि आप इस प्रॉब्लम को ठीक से सॉल्व नहीं कर रहे हो, आप प्रॉब्लम ही नहीं समझ रहे हो. सो प्रॉब्लम ये नहीं है कि अंडे टूट रहे हैं तो आपने उसके आपकी सारी प्रॉब्लम में एक ही चीज इन्वॉल्व है सॉल्यूशंस में, कि आप आउटसाइड स्ट्रक्चर को चेंज करना चाहते हैं. इसीलिए कोई कुशनिंग दे रहा है, कुछ ओरिएंटेशन, कोई क्रिएट बदल रहा है. बट द प्रॉब्लम इज नॉट इन द आउटसाइड वर्ल्ड, द प्रॉब्लम इज इनसाइड, द प्रॉब्लम इज इनसाइड द एग. द एग इज वीक, दैट इज द प्रॉब्लम, नॉट द क्रेट, not the road. Of course, you will not throw the egg on the road, but egg itself is not the problem. So उसने solution दिया, you just increase the little bit of calcium content in the food of the chicken. तो कैल्शियम खाने की वजह से अंडे की जो शेल है वो मजबूत हो जाएगी और ये प्रॉब्लम आपकी हमेशा के लिए दूर हो जाएगी. So this formulation was tried and it was 100% successful. So from that time and now, in all the poultry farms, the people can make the egg stronger or weaker the way they want by increasing the input, like the calcium content of the chicken.
But want to think that the this will I mean the impact the quality of the content, the food content of the egg itself. Cell is okay. Cell has become hard.
No,
But
but
what about the
no, but calcium is
other content
as
of this egg actually?
see. Yes, you are right. There may be some here and there things, but the main impact of the
Because your question I got it actually, because when I buy the egg from here, the metro actually, is the
Mhm.
two type of egg, high protein and low protein.
No, no,
I
that
told
is
him, I listen to me, argued to him, you know, how can you play with the egg? Egg is coming from hen only. How can you just play with this thing actually?
no, no.
It
Do
is
you know?
the natural
No,
activity actually.
no, no, no. There are even organic eggs also. कि अगर आप चिकन को केवल शाकाहारी चीजें खिलाएंगे सो एग की क्वालिटी अलग निकलेगी. So some people say it vegetarian egg even. There is a new term emerged. So
Okay.
the input recipe or input material is having a big impact on the output. You are
Yes, yes,
right.
that's right.
There may be some impact on the internal properties. जैसे हम लोग देसी अंडा खाते हैं तो उसका जो अंदर का स्फीयर है वो थोड़ा रेड कलर का होता है अगर
Correct.
आप खाते हो तो. सो डिफरेंट डिफरेंट इनपुट प्रोड्यूस डिफरेंट डिफरेंट आउटपुट. So this is the way this problem was solved, and the transportation of egg became simpler. So this is one like approach matters. So अगर वो बाहर की चीज पे फोकस करते तो वो प्रॉब्लम नहीं सॉल्व कर सकते थे. इवन इफ
Yes, yes. Just
देयर इज
like
सम
that input. in 2001 there was a campaign to just increase the sale of this toothpaste. So
Mm-hmm.
people came with innovative idea, ऐसा ऐड दीजिए वो दीजिए और ये करिए वो करिए मार्केटिंग करिए. एंड
Mm-hmm.
फाइनली वन से यू डोंट डू एनीथिंग, जस्ट उसका टिप का होल थोड़ा बड़ा कर दीजिए और कुछ मत करिए अब आप.
Mm-hmm.
तो
Right.
जो उसका जो टिप यहाँ से बाहर आता है उसका होल बड़ा करने से क्या होता है, वी हैव द मेंटलिटी जनरली टू कवर द एंटायर ब्रश. सो
Right.
नो मैटर वेदर इट इन और समथिंग, सो उसका होल बड़ा करने से सेल जो है मतलब जो है डबल हो गया, बिकॉज कंजम्पशन है जो है डबल.
Right. True.
ये तो किसी किसी मूवी में काजोल ने ये दिया था.
बट इन 2001
इट
में
इज इट
आई
इज
गॉट
इट इज
दिस
अ पार्ट ऑफ
कंपेन.
वन मूवी.
Okay.
यस यस.
So I don't remember. Okay. I mean, maybe. So now we just move further. We come to PVDC. PVDC is like polyvinyl. I mean, I believe this is readable because ये मैंने थोड़ा readable बड़े text के हिसाब से बनाया है. You all can view it. So this is called polyvinyl
यस यस.
dichloride and polymerization से इसको बनाते हैं. This is the structural formula of this. तो PVDC इंडस्ट्री में मेनली बैरियर के लिए यूज होता है एंड द ब्रॉड और द मेजर कंजम्पशन इन इंडस्ट्री इज 10 माइक्रोन और 12 माइक्रोन ऑफ पॉलिएस्टर फिल्म हैविंग 2 माइक्रोन ऑफ पीवीडीसी कोटिंग. दिस इज द आई मीन आई एम आल्सो शेयरिंग द industry aspect of this coating. This coating is mainly used in the do you know this application jelly packaging? जो बच्चों की जेली आती है छोटी छोटी डिफरेंट डिफरेंट शेप्स में. So they need a small window where the people can see through it, and they also need a barrier. So that is one application of PVDC coating, I mean on a film. So this is another story, but this is not the story, this is the part of the program. The PVDC was accidentally discovered. This was the person Ralph Wiley accidentally discovered PVDC in 1933. He was a college student who worked part-time in Dow Chemicals as a dishwasher. So while cleaning the laboratory glassware, he come across that he was not able to scrub clean. So then they made research, and there was a material they found. It was a dark clean, and initially it was called ionite, and then it was also called saran. And then gradually this material was developed. Initially, it was sprayed on fighter planes to guard against salty sea spray, and then gradually it was utilized in many, along with films and at many places. So this was not a intentional development, but it was accidentally discovered. This I just thought to share with you. It might be interesting. So PVDC main properties: it is a remarkable barrier against water, oxygen, and aromas. It has a superior chemical resistance to alkali and acid. It is soluble in oil and inorganic solvent and very low moisture retention regain. So above 125 degree it decomposes to produce HCl. So this is one limitation of PVDC. Otherwise PVDC is a very good barrier material. These are the PVDC properties. The films made from PVDCs are clear. Normally we use metallized polyester as a barrier material for food packaging mainly, but that is due to the nature of it is not transparent, so it is the metallized polyester is having many limitations, so we use PVDC in those places. It is also having a excellent cling properties, so which is good for the food wrap, as we sometimes do in shopping malls and all. This is expensive, so this is one drawback, that this is expensive and quite high cost. This is having an excellent gas barrier properties against water, oxygen, and many gases. So mainly the aroma barrier is very good in PVDC case. It is also having a corrosion resistance than PVC due to its higher chlorine content. It is having two chlorine, PVC is having one. So these are the main properties of PVDC. Now how we use PVDC in packaging is like it is applied as a water-based coating to other plastic films such as BOPP and PET. So this coating is responsible for the barrier properties like OTR and MVTR. It is mainly used for increasing the shelf life of the products. It is also give some glossy look. I mean, but not too much, but some glossy look and a good aesthetic. So these are the mainly used in BOPP and polyester. On the BOPP and polyester film as a offline coated. So there are separate plant for offline coating, like in my previous company Jindal was having, where we can take input film from our own plant and we can do PVDC coating or acrylic coating or many print receptive coating, but it is a separate operation after making film. Then there are certain limitations of PVDC. The main disadvantage of PVDC is it will undergo thermally induced dehydrochlorinated. As I told you, it can produce HCl on very high temperatures. So this is one limitation. And the degradation easily propagate. It can change its color from colorless to something yellowish. So these are the main two disadvantages of PVDC. Then we come to the acrylic coating. Acrylic is used very widely in paints, nails, plastics, and so acrylic is any compound that include acrylic acid or related compounds called acrylates. Typically, the products that are called acrylic is a polymer of acrylic acid or acrylate. So this is the definition which I have written here. So a polymer is a long strand of repeating sections. In this case, the repeating sections are the acrylic acid or acrylates. If we talk about the structure, this is the structure. N means it will be repeat, and this is called acrylic. Acrylic is mainly, I mean, acrylic coatings are mainly used with BOPP films. So the main properties are mentioned here. This is having an excellent machinability, very good gloss and transparency. So I want to explain these points, one by one. If you have seen the perfume bottles, and there's a carton over the perfume bottle outside that. So this film is used as a overwrap. It is having very high gloss, high stiffness, and barrier. So it is used in perfume, or one use was, if you have seen the Dove soap on a pack of three, there is a covering, the collation packing. So the white color is acrylic coated, so it is giving a very high rich look and high gloss. So normally the premium packaging are done with acrylic coatings. So this is having a broad seal range on acrylic coated surface and excellent high hot tech. Excellent hot tech. Hot tech means we can use these films on the high speed machines. It is having good aroma barrier, which I just explained. They are having high seal strength. These are printable with water based things. Humidity resistant. solvent-free coatings, and excellent dimensional stability and stiffness. So if I give you some examples like your, for example, the perfume cartons. So if you see the packaging, it is a very shiny and very tightly hold packet, very beautiful, very beautiful looking aesthetics. So acrylic coatings are mainly used there where the high aesthetic is required and good barrier is required both. Now we come to allox, which is the third one. This is just a small representation of how we make allox. So allox is mainly the aluminum dioxide. So there's a drum. By the use of aluminum and oxygen, we make allox. This is just a representation of how it is made. Allox coating are a very high barrier film. This is available in the transparent form. So that way we can make the films high barrier and transparent as well. So there are many places where we cannot use foils and metallized films. I'm sorry. So at those places where we need the transparent behavior and a very good barrier properties, we use allox coated film at that place. Allox coated is used mainly in the food packaging. Many times we use PVDC based structure and EVOH co-extrusions. It make the films even more high barrier. Moisture and gas permeabilities are not affected by high levels of temperature or relative humidity and are independent of the base film thickness, thus enabling maximum down gauging of packaging material. So we can use very thin films using the allox coating. And one important feature is that when we use allox coated films, these films are microwavable. So we cannot use aluminum foil or metallized films for this application. So this is especially we can make the food packaging for that. We can also do retort packaging with these films. So this is, I mean, in short, this is only these two, three things where on the very good kind of barrier is required, we use allox coating. Now it is another time of short story. Dr. Arya, are you there? Because I am not able to see anybody. So
See me, why?
okay, no.
Yeah, yeah, I'm here. How can I?
Okay, okay. No, no, it was complete silence. So, okay, so
No,
this
no,
is
no. See, it is going in an interesting way, and moreover, every expert talk
so
something is common, but the something is new actually. So most of the
okay,
time we try to learn it actually.
right, right. So now we are around mid of the session. Up to this time, this session
Can you
was
come closer to
more
your mic because the voice is breaking?
side the
Navneet, can you come to closer to mic because your voice is breaking? I hope it's some network problem.
Something is wrong with connectivity of
Yeah,
Dr.
yeah.
Navneet.
Yes, yes. Yes, yes.
Yeah. Dr. Raj, I request you to do one request to Dr. Navneet that
Yeah.
he is using some technical terms which may not be relevant or maybe known to the participants over here, particularly the students. Like one term he has a retort application, retort packaging. So I'm pretty
Actually,
sure.
I just want to ask him that question only. What is that actually? Because because we don't know actually.
Yes, basically, okay, Navneet is live now. So ask
Yeah,
him
yeah.
better, or I can answer.
Uh, Navneet, actually, we lost in between. So we were at our story only.
Okay, no
So one thing
problem.
is
Let me.
that there's a question from my side also and from the promoter also. What is this, the retort packing something?
Uh-huh.
So we are not
Okay.
technically competent in that particular field. So something is new. You should explain to us.
No, retort packaging is mainly used for the ready-to-eat packaging, where
Okay, okay, okay.
when we pack the food, it is packed in the hot condition and it is kept in the hot condition. So the film or the packaging should be able to withstand that temperature. This is called the retort packaging. So there is a complete laminate
So that is
structure.
for,
Mhm.
that's for how much time? Just to eat
Around
it
half.
hot, I mean, warm something?
No, it is not a very quick hot. It is like half an hour or something. I mean, different food may have different duration, but it's quite some time,
Right.
like half an hour or so.
Okay, okay. I mean that just to keep just a hot wrap type of thing, something.
It can
Yeah,
be minutes, Dr. Navneet. I think it can be minutes also.
yeah, it
In
can be
minutes.
minutes. It depends on the food, and sometimes it
Yeah.
can be high, but the food is packed in the hot condition,
Yes,
and
yes, yes.
and it is not a very quick heat and removal of heat. It will be quite some time. The
Mm-hmm.
film can shrink or the laminate can shrink in case we do not use it properly.
Yeah, yeah,
See,
right.
let me explain a little bit. See,
Yeah,
the application idea is not to intentionally pack in hot condition. Sometimes it is intentional, but 99% it is not intentional. It is because the process needs. We do not have a cooling time. Suppose some sauces are packing. So we do not have a cooling time.
right,
So it is packed in such a way, maybe at around 40-degree or maybe 50-55 degree temperature. So that is why this temperature and the packaging should not get shrink. So that is why this requirement is there, retort application.
right,
And another part is where we intentionally pack in hot condition because some food content they once they are cooled they try to capture some moisture or something from the environment. So that is why intentionally it is packed in hot condition.
right,
So before it cool down, we have to pack it and in a what you call barrier property like things, and maybe some what you can say vacuum packing sort of thing. So automatically when it cooled, it will become a sort of vacuum inside. So there is no oxygen. So food's life becomes longer. Okay, continue, Mr. Dr. Navneet.
so I believe the presentation size was a problem. When I closed the
No, no, no. Size is not a problem. Only the network connectivity is a problem.
uh,
Size से इसमें कोई मतलब नहीं है.
okay, ठीक
Yeah,
है,
yeah. Because actually bandwidth create the problem. So
right,
due to bandwidth, either video or sometimes this audio that means bent off actually. So that's not a problem. Just share it again actually.
okay. So maybe story we can discuss at the end. I think we can continue the PPT first.
नहीं आप बता दीजिए स्टोरी इन द मीन टाइम एक्चुअली नहीं तो वी वर बी एक्साइटेड के व्हाट वाज दैट स्टोरी
The
हमारा
story,
ध्यान वही रहता.
okay. So is it visible?
Yes, 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 it's visible.
Okay. So the story is about the two pots. So there was one elderly woman uh, having two pots, and one of the pot had a crack. And when she was coming from the stream to the house, so one pot was coming full and one pot was coming say half or main water was on the roadside. So after around 1 year or 2 year, the pot which was delivering the full water was very proud of his performance, of its performance, so called, and asked the lady that, I am delivering the 100% and the another pot is delivering 50%. So why you are not changing the pot? So why you are compromising on the performance on the another pot? So the lady answered, the another pot is having a crack. I am aware of that. Now, if you see closely the picture on the side, when there is a the crack,
Flower.
there are the flower is there. So मैंने वहां पर फ्लावर सीड्स डाल दिए थे जिससे कि आ, वो फ्लावर सब काम में आते हैं और रोड साइड फ्लावर हो गई है, जबकि आपकी जो साइड की ये बिल्कुल बंजर है, काइंड ऑफ. So we should utilize our imperfections in a positive manner, and this is life. And so this was the story. The utilize your imperfection in the effective manner. So I just thought to share with you. I like this story.
Then it's actually a nice story. Actually, we should use it actually.
So now, I mean, we come to the flexible packaging, various application, like how we evolved. So now there is no more text or formulas. It is only the pictorial session now onwards, and we can discuss or we can sometimes connect it more frequently. So this is how we evolve from the old type of packaging, the food packaging, to the new one. So originally there was some teen canister, we say in Hindi, and glass jar, etc. Then film and laminate structure came into picture. Like in Mumbai, the chips. There's a very famous chips packet which is in 5 rupee or maybe 10 rupee. The single structure. People are, it's a see-through structure, because it's a very fast moving product. Then Lay's and other companies made the same kind of product with high technology, like using high laminate. There was innovations in the product itself and the packaging structure as well. So this is a story how we evolved. So I'm just showing the different kind of food packaging used. This is the Parle biscuit, one of the fast selling product, started in 1939. So if you see the four categories, this is the different packaging. I have seen only the last two packaging, not the previous two. This is probably before my birth.
No, 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 no. This previous one was there actually.
Okay, so
It was there in blazer. In my blazer book, I have seen the last three actually. First
okay,
one I have never seen it.
okay. So
Maybe Dr. Navneet was using some high brand, not the glucose. That is why he's not aware.
no, actually, I have used that the paper packing with inside some kind of butter paper. So that the second one I have seen. The third one, which is the film, we are using right now, but the starting two pictures, honestly, I'm not aware of. I have not seen in practical. Uh, so the paper to this food packaging, if we talk about, this is a structure where we are using solid white BOPP film, which is the 15 micron. And other than the coating part, which I mean we are discussing here, the selection of film is also very important. Even in the same thickness, the pearlized films are also available, like from 18 onwards. But due to the having a good barrier properties, we cannot use the same kind of another white film in similar laminate. So this is a very high selling brand, and the packaging cost should be very much optimized. So this is a very good example of optimization. Like cost is also optimized and the look and feel is also the similar what they were getting in the paper packet or even better. So this I was talking about the previously polyethylene polypropylene TQ film. TQ stands for the thermally quenched. This is another term where there is a very small setup. The people can have the setup even one room where people normally use the granules. They make some kind of a small blown film in the tubular structure. And then there are some structures which are mentioned here, like four-layered structure in India, which is the BOPP, extrusion poly, METPET, and poly. So this is one structure which people are using. When we comes to the barrier, because we are discussing coatings, in many potato chips, people are also using EVOH. For I mean, not in India, but in abroad, I am aware that very for having very high shelf life and high aroma barrier, people are using EVOH as well in one layer. So this is about the potato chips. This is not a food packaging only, but like chakki atta is one food, but there are some cement bags also which nowadays coming into the laminate structures or in the plastics. So pedigree is one example where the very high level of laminate is required. I mean, there are another property as well as other than the barrier, like dart impact should be there, and these are mainly for these big bags. Then the new packaging comes like WPP bag. This is the normally for the rice, and these are the big bag. Then tea packaging. In tea packaging, there are many innovations going on, and the main challenge is to remove the metallized layer from inside. So metallized layer right now is in many tea it is the still this aluminum foil. In many places, this is replaced with the metallized film, metallized polyester films. So this is one development from the past. Before that, it was like in the jute bag, then some other packaging like woven sacks, and then this one. So because we are discussing the barrier packaging, some very expensive tea overwraps are made with the acrylic coating in order to retain aroma and for the good aesthetics. Then this is the oil packaging. I mean, this is not relevant to our subject. I'm just skipping it. Mouth fresheners. This is also a big segment. This is polyester is used in this because one is the barrier properties. The another thing is normally when we seal this material, the temperature is quite high. So the properties of polyester, which is the heat resistance, is used in this particular product, and therefore, I mean, it is used. Liquor bottles. However, I have never seen this packaging, but many places this is used in place of the carton. The sealed variant is available. Then there are various shrink sleeves. Um, Previously, I mean not previously. Nowadays, people are using PVC shrink, but they are also using PETG for this application because it is more environmental friendly, and this films has a shrinking nature up to 60 to 70%. These are the flexible bottles made like for the low end product like 1 rupee or 2 rupee. So this was the new innovation which was done in packaging. I have used some time back. Then these are the mini dose packages like Boro Plus. So many of them are having the aggressive material. For example, the Navaratan. So for that, we need the barrier properties or the fast relief. So these are the material where the barrier coating or barrier films are required. Then there's a cold seal application. which is also a kind of food. And this is also a laminate structure having the metallized film inside in order to protect uh, the material, the food. And cold sealed is done because chocolate is highly heat sensitive material. Then there's a packaging which is the diaphragm packaging for the food, where when we open the zip, this is again one tier openable metallized film. Now we are seeing in many products like Haldiram, Bhujia, and so on. So the barrier properties are protected, and this is done that way. Then the new development is in the double track locking system, which is there. And nowadays the pulses and many organic pulses and these things are coming into the packaging with a good sealable window. So some people have started using the coating material as experiment because the very good seal visibility is also required other than the barrier property. So this is one new things. Then there are gusset package which are used in tea, varnish, or these. So normally polyester film is one portion of the laminate, and then it can be metallized or depend on the product. Then this is a new technology. There is a laser technology. People make the because this is the dairy creamer, so it needs a very high barrier, and therefore people normally use sometimes aluminum foil or high optical density metallized film for that. So now films are not having very good tearing property. So by the use of laser, now we can have this, openable or easy tearable contour in one sense. Then these are the sleeves in pouch. So this is the one coating which I was discussing, like acrylic coating, uh, some overlaps like this one. I mean, we use acrylic coating on acrylic coating films on such collation packaging as well. It gives very rich look and protect the aroma inside. Then this is the flexi jar, which is the changed from the glass jar or the plastic bottle, polyester bottle jar. Now it is coming into the like 50 micron or more thick CPP films are used for this jar. This is changed from the original packaging. Then in some countries, the alcohol is also packed in pouches. So this is very aggressive material. So barrier is required. Like some countries, Africa is one where people, I mean, there are not too good economic conditions for everybody. So people just take pouch. I'm not sure what is the volume, like 100 ml or so. So they can have one dose and this is sufficient for one time. And you can see this is the 10 into 60 ml. This is mentioned uh, on this thing. Then there is new development like in terms of the profile packs. If you see the pack are not completely straight. There are some contours or designs is there. So and everywhere there is a barrier. I mean, I'm just showing the different kind of barrier films in this presentation so that you can get a good idea about what the companies are doing. Then this is the Taj Mahal tea. This is called a chain pack. So other than the barrier, the elongation properties of the film, the tearing property of the films are also important because In the chain, the top chain is having the weight of all the product which is lying below. So this is one kind of small packaging people are using. This is the portion packaging. Surf and Ariel, Easy, these are to be like a aggressive materials. So polyester is used in these products. Normally, the 2 rupee pack is available so that people can use it one time and can throw and then use the new one. So this is for the lower segment of packaging. Then this is the mainly clinic plus and shampoo type. These are the one-time use pack. These are a very high barrier material is used like quite high OD optical density film, which is the metallized one, and many other product in the laminate. This is the microwavable packaging which we discussed like PVDC is used for the for making the microwavable packing. So this is one example of that.
All these packing are the sorbitol free actually, because generally in polymers film and all this we use sorbitol also, right? In some of the
See,
packages.
see, depends on the need. Normally, companies issue one FDA certificate and the food grade certificate, and that certificate is having all the contents, maybe harmful or not harmful, and up to what extent is used or it is having based on the raw material they are purchasing, or sometimes they
Yeah,
also test the raw material.
yeah, generally we say that to microwave means food material with plastic, because, because in microwave temperature goes to a very high range actually with the heating,
Right,
microwave heating.
right.
So won't it harm the food content quality?
Yes, I mean it should be because I remember when I use popcorn, the natural popcorn and the popcorn from microwave. I never get the same taste. It is different
Okay.
because natural thing cannot be competed with anything. So for example, when we also take this ready to eat food, we get some taste, but it is not equal to what we normally use at our home. So the alternate is
See,
not the
yeah,
complete alternate, this is the equivalent alternate. It is a
some
close alternate.
arrangement. Yeah, yeah, some arrangement.
Some arrangement, yes, true. For
Okay,
example,
okay.
yeah, for example, dairy creamer. So even we say it is derived from the milk, but the taste is different. It is not similar to the tea which is made from milk, the natural milk. So yes, there is a difference. Then there are some security seals, which is not relevant. So I'm not discussing this portion. So I'm sorry, it is little bit speedy presentation because I think the
No,
time.
no, no, that's not
So
a time, is not a constraint. See,
so
the main idea behind it,
yeah.
we should understand, we should get the
So
informations and all.
right. So maybe we can
And, due to
we
actually restrictions and company guidelines, also we cannot also talk about so many things. Also, I can understand that part
right.
because
So
those are
maybe we can
the
yeah.
company rules and the regulations. Because most of the company, not only most, because all of them, because that's their business actually. They, how can they just disclose their something confidential, the secret part actually?
No, actually, Dr. Arya, the limitation this time I was having that when I was seeing many presentation, they are using some company related thing, and we do have some company presentation which are like bigger one. But this time intentionally I gave it into my personal capacity. So there is no film which is representing Jindal. There is no film or ink or adhesive which is representing Uflex. So it is something a general kind of thing which I shared with you. So
Yes,
therefore I
yes, yes.
yeah. So please excuse me for that. It was
No,
not
no,
coming to
it
me.
was actually uh, It's very good one, mean the
Hello,
wonderful one. And luckily, we have the Harinder Singh
Dr.
also asked. Yes, Harinder.
Yes, sorry to interrupt. I think you wanted to say something, then you can continue, Dr. Rajkumar.
No, 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 no. You asked the question because
Okay, Dr.
I
Navneet, first of
excuse
all,
me, excuse me to
yeah,
interrupt everyone. I have one valid point over here because today is our last session, so we are meeting last time. So can I
yes,
request
yes.
everyone to please continue your
And on the
video
video.
and at least introduce yourself first.
Yes, yes, yes. I the request every time.
Yeah.
So
first we can discuss or we can just go for this discussion. Uh,
okay, okay.
Better you start your video and then let us discuss.
Yes.
Let me
okay,
see.
actually, I'm not in formal clothes right now and
No, that's
taking
okay.
my
That's
video.
Don't
fine.
put
That's fine.
who needs the clothes? Just face is enough only.
It's not a business meeting. It is a formal.
Okay,
Yeah.
Yes, yes, yes. Oh,
okay,
you
I
know,
think I think it's enough.
actually.
Not smart like Dr. Rajkumar. He's actually my classmate and
Don't
looking
say
younger and everything is good
you
with
are
him.
doing
Okay,
a lot of the
actually,
research, and I am doing a lot of short-term courses, and I am saying I am working in a different part. You are working in a different part, actually. So
yeah,
Harinder
yeah.
is my MTech classmate from IIT Delhi. Actually, we did masters together from IIT Delhi in
Uh-huh.
2002. So yeah, yeah. Continue now. You ask your question.
Yes, yes. Actually, Dr. Namni, this was very nice presentation. Actually, my question is related to the packaging films. You have
Harinder, voice is
focused on
breaking.
the plastic packaging. Okay, you have focused on the plastic packaging, and my question is related to this that we are developing edible packaging, biodegradable packaging.
Mm-hmm.
Now, when we compare their performance is always lower than the synthetic packaging or synthetic chemical packaging.
Mm-hmm.
My question is that can you give us some rules of thumb and some values for OTR, WER for different products? And another question is that in case of blow molding and other techniques, what kind
Mm-hmm.
of properties we look that whether we can do blow molding on some material or not. Like we have
Mm-hmm.
starch films, we have cellulose film. Can we go
Mm-hmm.
for blow molding or solution cast method we have prepared? And I have seen some paper, I think blow molding, they are adding some polymer, again
Okay.
PVC or that.
Mm-hmm.
So can you just give us some,
See,
give throw some
the
light?
yeah, yeah, your first question, like the OTR and WTR values, the
Yeah,
very good WTR and OTR values of the laminate are treated if it is like 0.03, 0.03. I mean, OTR
okay,
and WTR, this is treated to be a very, very high barrier film. Even
okay,
if it is like less than 10, then also, I mean, it depends product to product and the shelf life to shelf life. So if you go to the higher shelf life, the
okay,
barrier properties in the same proportion need to be improved. But normally, when we talk about replacing the aluminum foil, I mean specifically, so aluminum foil is having the um, uh, say value zero point zero 0.01 or zero zero, let's say, because it is close to zero. So any polyester film which is having the value of 0.03, 0.03 is sufficient on a practical ground to replace the aluminum foil. And it is a food grade and available. This is also sold for the dairy creamer application. Even the performance of laminate is slightly compromised because now we are comparing the zero point zero 0.01 to zero point zero 0.03, but that is okay. It is making a commercial sense to change the polyester to the laminate made only with film. So this is not an apple to apple comparison, but it is like what is practically viable in the, in terms of the profitability and acceptability in the market. So the thing which is acceptable in the market and making profit is a win-win, because there are many structures which are highly overstructured. I have seen many laminates where, for example, people are having X bond strength. So when I am asking what is the optimum bond strength you need, so their simple answer is since 15 years we are doing this, we will not change this because there is no benchmark. So it is possible that even the half bond strength is also sufficient to that particular laminate structure, but they will not change because the many companies are not having risk taking capabilities up to that extent. The second factor is sometimes the value of your packaging is too low in comparison to the product which is inside. So people are least bother whatever, even your packaging is having high cost or low cost. I give you an example. I purchased one, sorry, delete this line. I purchased one. I know a company, Dior, Dior. So it is a cosmetic company, and on one airport when I was seeing the products, so the one product was having 60 euro, 70 euro, the cost of the product. So the packaging cost is hardly anything, even they are using the highest or the costliest packaging available in India. So they are intentionally not changing the product because this is the something, the main premium is coming on the product which is inside. So they need the expensive this one. So sometimes the profitability and these things are interconnected. This is based on your product and your intentions.
Okay, and
Now, coming to your second point, you will need to allow me some time regarding molding, because my there is one next company, the Uflex, which are just now coming into the molding this thing. So I will discuss with them, and then I will be able to give you some good and fruitful thoughts on that. So I have my number. I will share with you, and we will be in touch on that.
okay, that's very great answer. And I think OTR, WVR values may be available in some handbooks also. And
Right.
another question is which of these polymers which you have mentioned is mostly is biodegradable to the highest extent? Sorry, biodegradable. Now, my research is aimed at replacement of these plastic packaging. I was surprised that the volume of the
Harinder,
production of.
means the awaz is, the sound is not coming
Okay, okay.
properly. So maybe you should come
I,
closer to mic.
okay. I have come closer to the mic now. Thank you. Now I'm audible, Dr. Arya.
Yeah, yeah, completely audible.
Okay, now which of these polymer is biodegradable to the highest extent? Because seeing the volume of production of these and the use of these polymers in packaging, I think we are hurting the environment. I know about life cycle assessment also and these things, but certainly we need to replace this. And which is the polymer you suggest can be incorporated into the biopolymers, sorry, with biopolymers to make packaging films for like covering for fruits, vegetables, or just like you also shown that alcohol. Now alcohol is
Yeah.
coming in packaging film and it will be used like anything.
Yes. True.
Yeah.
In my opinion, the discussion around the globe will change after COVID. Now people will search how to not make a film biodegradable. And my question is why we need a film which is biodegradable. We need to change our attitude to handle the film properly. The film is not a problem or plastic is not a problem. The
Hmm.
problem is how we are handling the plastic. For example, today is the COVID situation. If I give the medicine or fruit in a, for example, there is a fictitious biodegradable film which is produced, for example, how many people will purchase that? No one will purchase that today
Yeah, yeah.
because they have a risk that there is some penetration which may happen to inside.
Hmm.
So now coming to your specific answer to your question, in my opinion there is no film till date which is completely biodegradable. There are certain experimentation which are going on, and some rosy terms like oxo biodegradable and something else are existing, and these are even more risky experiments which the whole world is doing. But see, by nature polymer is not degradable, at least by far, as per my experience it is not degradable. Let me put that way. And up to the latest research,
Can I interrupt here?
hmm? No, no,
Actually, in the biodegradable thing,
no, no. I'm
people are working on
no, no.
that.
I'm coming to that point.
Let me add, no, let me add first here.
Okay.
So, so in biodegradable thing, as you said, first thing, it itself is not biodegradable. That is not right, actually. So at present, we are the doping something just to means enhance its degradation, actually, doping some material inside that film, and
Mm,
that too also needs some particular type of climate also. Naturally, as you said, it won't in the normal environment, it won't degrade just like that only. It needs
no, but
some environment. For
no,
that,
but
as you said, the management and handling matters a lot. The way we are throwing a plastic bag, just like that, also biodegradable will also not help in that way also, because you have to collect the material at proper place and provide a suitable condition for degradation at least.
no, but Dr. Raj, tell me one thing. For example, you made a bag which is partially biodegradable. Take a simple term,
Yes, yes,
right?
partially, yeah, partially. It's not the
Partially
100%
degradable.
true.
It will
Yes,
take
yes, yes.
take some theoretical values. It will take 1 year to degrade under sunlight.
Correct,
For,
correct.
for
Right,
example,
right.
what I understand, the people who are, I mean, with due respect, if someone is working on that, my intention is not to hurt someone. After 1 year, if it degrades, no one can guarantee it will degrade into two parts or three parts. I mean, the one bag will be now a two-pack structure or a three-pack structure because you are doping something in it. So the portion
Right,
which
right.
is able to degrade will degrade, and the portion which will not be able to degrade will not be able to degrade. So it is quite possible that your whole, after a degradation, your whole one pack of bag is now is having 10, 50, or 100 pieces after the degradation. So to collect the plastic,
Yeah, yeah.
it is easy to collect one bag or it is easy to collect the 10 bag. So these are the real challenges on the practical ground. On theoretical ground, it is a we are going into the positive direction. But once there are some NGT which is governing many things, how to collect waste and all. So collection should also be considered whenever we are going for the development of any such study. True, you have successfully break into, for example, the 1 kilogram of polythene now is at 10 gram. So you have reduced 90%. But if you make the 10 pieces, then to collect the 10 pieces is easy, or to collect one piece is easy. These are the real challenges world would have.
Yeah, actually, I agree for that part. Actually, and people who are working on biodegradable things also, they are working on that aspect also. First, we want to make it the degradable the cycle to, let's say, 4 month or 5 month or the 6 month. Currently, it is very slow actually, and that too also that the ingredient which you are the putting to make it degradable, that also is a costlier end also. So that's part also because is also going on. And unfortunately, what is happening? One more thing here, that whoever is working on biodegradable, I mean the aspect, people are immediately patenting that. So it's not coming in public just to work on a. Everybody is not going to work in that field. So because the a lot of improvement happens when many people works in that particular field, right? So somebody is doing something, somebody is doing something. So probably we may end up with something good. But now what is happening that if the somebody got something also, no, if even 0.1%, he or she is patenting that thing first or keeping it at one particular place. So if unfortunately that group would start working in that field, that work is nowhere actually. That is just there in paper only.
See, normally people are using many proteins or starch or many such things. I'm little bit aware about these things, but I mean, I have no specific answer because in my knowledge, films is not biodegradable as on date. When I say films, these are the films which are widely used, like BOPP and
The
polyester.
commercial, with the
Yes,
commercial application, yeah, yeah, you are true
yes,
actually. That's correct. There's no doubt in that actually.
yes.
Actually,
So, but
Doctor,
yeah,
oh,
Actually,
sorry, you are. I'm sorry to interrupt.
basically, we should not use the term biodegradable here. We are trying to disintegrate the film.
Yes, yes,
We're
yes,
just
yes.
just putting some small pieces of it. So polymer polyethylene or polypropylene is not going to see. Once we are saying biodegradable means वो पंच तत्व में विलीन होना चाहिए. पंच तत्व जो धरती के पांच
Exactly.
मूलभूत हैं. So I am pretty sure what Dr. Navneet is saying. It is quite impossible that we cannot biodegrade any polymer as of now. That is true. So we are just disintegrating the film.
That's okay. That's okay.
Am I right,
But
Dr.
yeah, yeah,
Navneet?
yeah, 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 yeah.
yeah,
Both
yeah.
are the
So
views
my, I mean,
presented. Yeah, sorry. Okay, please continue.
yeah, my opinion, a constructive opinion rather, because the purpose was not to discourage any study which may be going on. In industry, we say the bigger problem we solve, the more successful we are. So now we are actually searching a very broad problem of biodegradable. So a good
I,
approach may be that we take one example where even partially biodegradable films may be successful theoretically. Let's not make it a universal agenda that everything will be biodegradable, bottle will be biodegradable, my Maggie pouch will be biodegradable. Let's concentrate on 2 3 application where this thing may be viable. Then it may be more fruitful and acceptable by the industry.
yes, you should refer your first
Mm.
story. Change the approach.
Yeah, that's okay. That's okay. That we, but I will just. I'm very disappointed by the Indian scenario that even if you say that we can collect plastic and this, that is not going to happen, and there will be uh, because we have already seen so much harm to the nature by these non-biodegradable or plastics. And slowly we are changing our approaches that we are replacing plastic from our homes and other things. Yet, yes, plastic is a magical material, no doubt. The way it creates barrier, the way it protects the material inside, the way it is lightweight, cost, etc. It's no doubt, and it will continue for many many years to come. And yet, the recycling problem, I don't think either the even if the laws exist, we are not going to follow it. You have just seen the law, what is happening in Delhi and what is happening in other countries. Only thing is that we can spread the awareness to go to more bio-friendly, if not biodegradable. And then again, there are many examples where biodegradable polymer packaging has been commercialized in many parts of our world, including India. So I think uh, we need not be disappointed and keep on doing research. And I've seen plastic being degraded. And we have also working on plastic degradation or thermal cracking. That means to plastic to more bio-friendly fuels or chemicals. At least it should come in this cycle. It may not come into the natural cycle, the cycle created by nature, but still, man and nature have to create a balance and create a new cycle where plastics can be converted either into food materials or to fuels or to some other thing like it has to be. I think I know that you are not discouraging any of us, but still I thought to put up my views. Thanks.
No, there may be a midway. I mean, rather, I want to make this discussion a fruitful,
Yeah,
you
right,
know,
right,
uh,
right,
there
right.
may be a midway which can be a win-win situation.
Yeah, right,
See, whenever there is a software, there is always a virus, and when there is a virus, there is an
right.
antivirus.
Yeah, yeah, yeah. Very good
So,
example.
because right, so you cannot change the mindset of people, but you can be like antivirus. Let me tell you what I mean, by this thought. Because I have visited many countries because I was working in the international market. Many countries have solved this problem in some or the other innovative way. If
Yeah.
you just giving one or two examples, some countries like I believe the country name was Ireland is having a
Mm-hmm.
bag tax. If you purchase a bag, you need to give a tax to government. and they are increasing the tax if you are purchasing more. So there is a
Same
quite
thing to happening here also.
no, it is
If
not
you
up to
go to the
no,
market
it is
also,
not
Pantaloon is also charging 10 rupee per bag.
no, it is
Yeah, yeah,
not up
but
to
no recycling.
no, it is not up to that extent. They were monitoring
Yeah,
very
yeah.
fast, and it is practically done. And now the people are using 10% of the bags which we were, I mean, in that range, which they were using few years back. Point number one. The second point, which may be more relevant to you, we can demand government or we can do some kind of research like Israel. When I went to Israel, Tel Aviv, they are having a very unique kind of practice. They are having a lot of bottled water, you know, the polyester bottle, polyester, this PET bottle, and there is no bottle on the street. So they make some mid-sized bucket on the roadside where everybody is having or drinking the water and putting the bottle in it. So people will use plastic, but in case there should be a midway solution to organize the waste. So you can do your experiment that in this condition, if the waste is collected, then it can be this degree of biodegradation, then it may be a viable solution for India, where the government may also agree, the people may also agree, and your research may also add some value.
Yeah,
So this is my submission. That,
Navneet, I think that you are far away from the mic,
that's great.
so the
That's great
voice is
answer.
breaking.
yeah, now is it okay now?
Uh,
Okay, okay. Yes,
yeah,
that's very great answer. We can ask
for the
other.
interest of audience, like Dr. Navneet has introduced, there are so many options available worldwide. Different countries are trying different way. Even in India,
You are
government is
actually very far away from mic, or I
yeah,
lost the
government
connection.
yeah. I'm audible now.
Yes, yes, you are audible.
Okay, so government of India is also trying to impose some certain rules. Like they have made one agency that and brand owners of the produce, they are captured in such a way that at least 50% of your packaging you have to buy back. And you have seen that practice has already implemented in few states uh, strictly that the producer, not only the producer but the brand owners. For example, Amul Dairy, Mother Dairy, they are not the producer of packaging material, but they are the producer of the food, milk. So they are user basically. So they have done this exercise that one single pouch you can resell in 10 pesos. Means if you collect 10 pouches, this company will buy from you in 1 rupees. So this practice is already imposed. They have given certain guidelines. The government of India has given certain guidelines that the brand owners are responsible for collection of this garbage. So the things are going on. Not only that, certain experimentation has already been done that this scrap you can use on constructing the roads. So which is of a very high, good quality roads. So certain things are going on, and people slowly realizes that as of now, again I'm repeating the same word. As of now, there is no device or no chemical is available which can make these films biodegradable. Research is going on, but these are practices which is being implemented even in India. We are collecting the garbage, we are collecting the polymers and all those things, and reusing for carpeting the roads.
Yeah, yeah, that's good example. These days, I think IIT Madras has done. No, I
Yeah.
think so. Yeah, yeah,
Yes.
yeah,
Yes,
yeah.
that's
You're
right.
right.
Yeah. So Harinder what we can do, we can be in touch, and I will be
Yeah, yeah,
happy
sure.
to be connected with you on this topic. And I have
I
some connections overseas as well. So I will be
okay.
happy
Thanks.
to, pass on any information, maybe from institutes, maybe from some research institutes
Yeah,
to you. So we will be in touch. And in
yeah,
case
yeah.
any of
Thanks very
the
much.
study or any connection or, as Raj is saying, there are many hidden inventions which are not known to other. So I will try to be connected to you
No,
and
no, no.
to help
Those
you
are
whatever
not
possible.
hidden. Those are my mean to say that everybody, whoever is doing the little work in the biodegradable and all this, now people are very much crazy. Everybody is filing patent first. before exploring anything too much, just do something and file the patent. Everybody is the hurry in the numbers in that way actually.
See, Raj, it is
So
Raj. It is
that way the things are not getting explored very much.
no. But Raj, this is based on your intention. You need to decide. You need to make an art movie which will collect 10 awards with no commercial value, or you want to make one movie which is not winning any award and is making 200 crores of business. So this is basically your intention, what you want to do in life.
Yeah, right, right.
Good.
It,
Okay, Navneet, I have one more question. Can you, being a expert of
Yeah,
films,
yeah,
can you
yeah.
throw some light
Any other
the
question
difference,
from
the
any
difference?
participants? They want to ask the something.
yeah.
Yeah.
Yeah. My question first. Can you throw some light on the difference between RPET, APET, and GPET?
I have very little knowledge on that. I'm sorry, I have not worked in this field.
Okay.
So, I want to be honest and uh,
Okay, great.
yeah,
Thanks for your answer.
yeah.
Yeah, any other participants, please? Rajkumar, Dr. Rajkumar, you can invite them. Participants.
So yeah, thank you very much actually. So if there are no more questions actually, so we will end this session here
No,
and
Dr. Raj.
then after I
My
think
request is still
maybe
no,
10,
Doctor
15.
Raj. My request is still
Yeah, yeah,
unnoticed.
this is me open to all participants and
Yes,
they
No,
should
I
interact
think
actually.
people are not, visible. So I think
Bharathan?
they should.
yes, that is why my request was.
That
My last request is please be visible
I
and
think
introduce
network is
yourself.
creating some problem. My network is poor or I can't hear anyone.
So let me repeat. My request was that everyone should be visible. Please open your or switch on your camera. Let us show your faces. We want
I
to
am
see the
frequently
shine on your
losing my
face.
computer network actually.
You can
Great.
invite, please. Kindly
Yes.
invite them. Dr.
Please.
Gagyan.
Dr.
Gagyan.
Shubhendu, yeah, thank you. Let me take names one by one. Dr. Shubhendu Chakraborty, can you please switch on your camera? Yes. So a lot of people are coming visible now. Great to see your good faces. So I can see the glimpse and the shine after so many long sessions on your faces. So you learned a lot. Great.
and how many of you are students in this? I mean, can you, Raj, who are the students in this panel? I mean, in this session?
So out of 16 participants, how many are students? Shush- Uh, Shrishma Gopal, can you please introduce yourself?
So I'm Srishma Gopal, first year MTech student of NIT Jalandhar. Um,
Ritu Sharma. Ritu Sharma, can you please be visible and introduce yourself?
Yes, sir. My name is Ritu Sharma, and I am from MTech first year from NIT Jalandhar.
Yeah, Achal, you are also studying?
Yes, sir. I'm also MTech first year student.
Okay. Krutika.
So even I'm MTech student.
Okay. So you are so many students and you have no questions. Is it little bit surprising?
Sir,
You
I
should
have
have.
a question.
Sorry, my PC got that disconnected actually.
Mm-hmm.
So, can you hear me now?
Yes.
Yes, yes. Now we have all our
No,
students here.
yeah, we are discussing. Yeah, Raj, we are discussing with them. So, as I told you, in the end of the session, we can have a short discussion. Discussion may not be on the subject topic, like on the values, barrier values, and all that, but in general, in case students want to know something because we are representing industry, and in case you have any doubt, any inputs, or anything, so we will be happy to share, because in our initial career we also made many mistakes, or we learned a lot, so we can share which you can benefit. I mean, in case somebody wants to have any interaction, anything you want to ask, we will be happy to discuss.
Sir, I want to ask something.
Mm-hmm.
Sir, as you mentioned, sir, for the tea packaging nowadays, metallized polyester film is being used. Sir, my dad is a tea planter, and we
Mm-hmm.
sell tea in 1 kg packets, and we normally use poly bags for that, and we heat seal them. So they work
Mm-hmm.
fine for a period of 2 years. Like they don't lose their aroma or taste is fine. So, sir, what kind of advantages will we have if we use this metallized polyester film? At the same time, sir, what would be the cost regarding the same?
See, I give you little bit broader answer. When the tea is manufactured, it is initially packed in 25 kg bag. 25 kilogram bag is made initially. It is having the structure a paper and a metallized polyester. The 12 micron metallized polyester is laminated to the paper, and then the 25 kilogram tea is packed in that. Some people also use aluminum foil in place of metallized polyester. So what happened then? It is exported or sometimes transported to some other places, and people open it and then they repack to smaller one, which you are sharing 1 kg. So when you are saying its shelf life is already 1 year, so it may be more than 1 year because you have not tested after 1 year, right? So you need to evaluate whether the material or the packaging which you are using is actually overstructured or just okay. In case it is overstructured, you can replace or you can make inferior packaging that will give you some more economic sense or business sense to your packaging. And there you can use metallized polyester with a optical density approximately 3. Generally, metallized polyester is available in the optical density 2.2. This is the standard. So, my recommendation is that you can try metallized polyester with optical density 3, and then you compare your existing one and this new one. In case the shelf life which is required is meeting this thing, then you can replace in case you are finding the commercial value.
Okay, sir. Thank you, sir.
Yeah.
So, anyone else wants to ask
No, no, no,
anything?
no, no, Dr.
So,
Raj.
Dr. Navneet.
Today, your question should not be anybody wants to ask. At least each student has to ask one
Huh?
question.
And you can also ask any question which is not related to technology.
Yes.
Let me start, I mean, my question first so that you can get the idea of what I'm talking about.
Eh,
Let,
yes,
let me,
yes,
yeah,
Dr. Navneet. It's an open
yeah.
forum now.
I'm
Yes.
just sharing my experience to you when I was in college. तो हम लोगों ने प्लान बनाया कि कैंपस में फ्लाइट से जाएंगे फ्रॉम एचबीटीआई कानपुर and it was my first ever journey in flight. So 3 students agreed, and 1 student who was probably the one of the topper refused. He, so I'm also sharing, Raj. I never shared this to you before. मैं एयर इंडिया के ऑफिस गया और 50% डिस्काउंट मैंने लिया वहां से, एंड ट्रेन के टिकट के बराबर में हम लोग पहुंच गए इंटरव्यू देने. सो नाउ द क्वेश्चन